Okay, in this video, I'd like to continue with our practice problems for day 58. Now, number 4, I started reading this and realized that this one's a little bit different than what we've already seen today. Liam was born in October of 2009, and his grandparents put $20,000 into an account. That must be nice. But they did not add to it anymore. They put that money into the account and walked away. So because this is a one-time investment, we need to switch back to the formula from yesterday and take the principal times 1 plus r over n to the nt power, and we'll call it quits from there. So the money was $20,000 p-value times 1 plus, now 3% interest is what they're trying to say here, that yielded 3% interest. So we'll write this as 0.03 compounded quarterly for 4 times per year to the power of 4 times 18. Now I'm going to use Desmos to go ahead and calculate this. 20,000, no need for a fraction to begin this one, times 1 plus 0.03 over 4 to the power of 4. Oops, I'm going to need parentheses here. To the power of 4 times 18, since we're walking away from this for 18 years. And it looks like the $20,000 that was set aside for Liam has turned into 34,251. 34,251 and 5 cents. Okay, now number 5 here. Fatima opened a savings account with $7,500, and she decided to deposit that same amount semi-annually. So it looks to me like we've got an investment or principal amount of $7,500 that's being invested semi-annually. So that happens twice per year. Our N value is 2. We've got an R value of 0.03975. And let's see here, we need a T. So reading on, we see the future value. What is the account worth after 10 years? So I knew that the formula required 5 letters, P, R, N, and T. P, R, N, and T. And we can calculate our A value from that. And it's this A value that gives us the future value, or the total that it'll be worth after time is up. And this is what the expression should look like on paper before you go to the calculator. Here again, that exponent does need to be on the innermost set of parentheses, so I've got it in the correct spot. And now I can go to Desmos and evaluate this expression. And I again just modified the calculation that was working for me already. So $7,500, 3.975% interest, semi-annual for 10 years. Looks like that investment, wow, is worth $182,003.62. $182,003.62. Now that's pretty nice. That's how most people become independently wealthy, if they are investing their money. Now $7,500 is a lot to invest at any given time, but this is a savings of over 6 months' time. She's only investing semi-annually, so every 6 months she puts in $7,000. And if you're working full-time and you don't have that many bills to pay, maybe you're driving a paid-for car, or you don't have student loans, then you surely could afford $7,500 every 6 months to invest. Now, this last question gets particularly interesting. We can actually graph this future value function. We can actually graph what her account would look like over time. And the way we do this is we change that 10. So change the number that we used as 10. She did invest for 10 years, this guy right here. Change that back to the letter X. Change the number 10 to the letter x. And by doing so, that's going to create a formula, or I should say an equation that can be graphed, where x represents our time, and we should see our account value grow with time. So here she is starting at $7,500, and after time passes, an exponential growth curve would indicate that her account balance continues to grow. Now, our question is going to be, well, when does her account reach the $1 million mark? How much time does she have to save this money for in order to reach $1 million? And we'll be able to do that by finding this intersection of the $1 million line with the x-axis. And that's exactly what we're going to be looking for. So I'm going to jump out to Desmos and walk you through this. I don't need this calculation anymore, so I'm going to erase that. And for good practice, I'm going to move my cursor out front and write y equals. Just to make this an equation, we've got y, which represents our total amount. Our total amount is equal to, and we're going to use our x-axis as our independent variable, so we'll change 10 to the letter x. Now, if I adjust the zoom, and I can do this pretty easily on my computer since it's got a touch screen, you'd be able to do exactly the same on yours if you've got a touch screen, or if you've got a tablet or a phone that you've got the Desmos app installed on, you can do the same. So here's that exponential growth curve. She starts with about $7,500 after that first investment. And as we drag our cursor along the way here, we can see how much her account is worth after a certain amount of time. So if I drag out to about 10 years, I'll see if I can get my cursor to stop there. There's our 10-year investment mark. And can you see the Y value? Oops, $182,003.63. So that matches with what we had just a second ago. If I can get my screen to respond here. There we go. There's that $182,000 and $182,003.62. Let's extrapolate a little bit further. How much farther do we have to go until we reach $1 million? Well, at 30 years, we're looking at a little over $840,000. Let's keep going. Keep going. Up, we've made it over $1 million now. I'm going to back up here and see if I can get my cursor to stop. It's going to be very difficult for me to get that cursor to stop precisely at $1 million. Now, that's okay because we can estimate the result. We can say that it's going to take about 32.8 years. But we can also make a very precise result too. If we click on another line, we can press Y equals and give it a target, $1 million. So here we have y equals $1 million. That's our goal. That was our target line. And we want to know, well, when does our curved line, when does our exponential growth line seem to intersect that target line? And by just tapping on the screen, we can see a more precise answer. It looks like 32.894 years is how much time we'll have to pass in order for her to have $1 million in the bank. So we'll say this x value here, we kind of predicted what that shape would look like. This x value was 32.894 years. It seems like a long time to wait, but you know, in the grand scheme of things, it would be pretty nice to have $1 million in the bank account after, say, working for 32 or 33 years and investing along the way, because I certainly could live on $1 million, and I hope that you could too. Well, I hope this video helps. If you have any further questions, please make sure that you send me a message through Schoology or by email. I'll try to set up a meeting with you virtually if we need to, or I can record another one of these videos to help you more specifically. Just let me know. Thanks for watching.